Hello everyone, my name is Austin Shaner and welcome back to my channel. We reached episode 5 of how to build a guitar in Fusion 360. Now in the last episode we went over what I deemed the infamous headstock transition. We went over why it's the most complicated part of the guitar to model and what strategies you could use to make it work for your design, whether that be fillets, lofting, patching, etc. Now we're actually almost done with the guitar. Most of the hard work is pretty much done. So we've got the main portion of the body, we've got the neck, we've got the headstock, we've got our laminated top, and there's not that much more to do except for the nitty-gritty details. So today what I'd like to do is get the truss rod installed into the truss rod slot, the fretboard, the fretwire, the nut, and the bridge in place, and that should give us enough information so that we can know where to place the tuners, where to place the pickups and the pickup slots, and our electronics cavity and knobs, etc. in the final episode. So this is going to be the second to last episode of this series, and I appreciate you guys joining me along the way, but let's get to it. Okay, so first things first, we want to get the truss rod slot cut into the neck. So let's hide our laminated top, and let's talk about the truss rod. So there's a couple different types of truss rods that you can put into a neck. There's what I'm going to be using is a spoke wheel style, where there's a spoke at the end or the heel end of the neck, rather than the type that protrudes outside of the headstock. Now, the reason I chose to go that route, other than looks and accessibility, which I generally prefer the spoke wheel style anyway, but because I like to place my volute a little bit further back, that ended up making this section of the neck a little bit narrower than I would have liked. And so I don't want to cut into that neck any more than I already have, and to prevent any disaster down the road. So what I actually would like to do is cut a spoke wheel style, which means it's going to be from like here on the neck all the way to the heel. So what's really nice is on StuMac's website, the Spoke Nut Hot Rod Truss Rod, it's quite the name, they have the dimensions right here. And that was enough information for me to go ahead and model my own. It took a little bit to extrapolate some of the dimensions out of there, but I was able to go ahead and model a truss rod, and I'm going to use this for my dimensions to cut into the neck. So let's see where we're going to start. So we're going to start from the spoke side up. So we've got a 1/2 inch diameter spoke connected to a 0.3125 inch diameter shaft connected to this block right here, which we'll end up cutting. So let's go back and let's start from right here. Okay. So what we need is a midline. Make that midpoint. And we need it to be at least a 1/2 inch, but really because you're going to be rotating this and there might be a little slop, give yourself a little bit more. So let's do 0.625 inches to give ourselves a 1/16 on each side. And then we'll go ahead and just make it a rectangle like that. Okay. Now, what is the distance from here to the bottom of this? Actually, we can distance it from the top. So we've got 0.0729 inches from the top of this surface to the top of the spoke, 0.0729. So let's give ourselves a circle, make it a construction, make it 1/2 inch. Let's make it centered or vertical to the midpoint. And let's dimension from this arc 0.0729 inches. Okay, so that needs to be the very bottom. That needs to be at least where this square needs to go down to. And since we went ahead and gave this, let's do that. Make that vertical. Give ourselves another line down here. Make that vertical. That way we can keep the distance equal on all sides. What we can do is just make these two equal. Actually, I guess I didn't even need that. So there we go. So that's the channel we need to cut out. So how far do we need to cut it out? So we need to cut at least the thickness of this, which is 3/16 of an inch, or 0.1875. I'm going to give myself a little bit more breathing room than that. So let's go ahead and cut it back 1/4 of an inch, negative 0.25 inches. Okay, so that's where the spoke is going to sit. Now we need to cut room for the shaft. So let's see, we've got 0.3125 inches. And what's the distance from there to there? Actually, we can just do it on center. So let's sketch on this surface. Pull up the last sketch that we just did. Hold on. There we go. Okay. Let's project this circle in. And then what we can do is make that a construction line and add a circle there, 0.3125 inches. Actually, I'm going to undo that. Instead of bringing in the circle, let's just bring in the center point. Circle, 0.3125 inches. Okay, make that a construction line. And let's do the same thing. So let's go rectangle here, midpoint. Okay, and then let's make here to here. Actually, I don't want that at the midpoint. Let's do it from here to here. Okay, so we want to give ourselves, let's say, a 32nd of an inch. We don't need that much clearance here. So 0.03125. And now let's do the same thing here. Make those horizontal and make these equal. There we go. So now we have our width so that we have a 32nd clearance on all sides. And we need to cut that back how far? So from here to here, 0.625 inches. Okay. So cut that back, negative 0.625 inches. Okay, so now we've got that. All that's left to do is to cut from this surface back to here, which is 17.4375 by how wide? By 0.2188. So now let's sketch on this surface. Give ourselves another rectangle. Project that in. Make those midpoint. Go 0.2188 inches. Let's double check that real quick. 0.2188, yep. And then by how deep? 0.4375. 0.4375 inches. And how long? By 17.4375. Negative 17.4375 inches. And there we go. Our truss rod slot is done. So let's go ahead and drop that in. So grab my truss rod, drop that in. Okay, let's rotate it a bit into place. 90 degrees. Okay, and then what we can use is we can join this to our sketch. So let's pull up our sketch. And let's pull up the other sketch. Okay, so I want this circle to be joined to that circle right there. That way it's aligned in this direction rather than up against this side of the body. Hit OK. Hide our sketches. And there we go. So you can see that the spoke is going to sit inside this channel. It's got enough clearance on all sides. I'm not actually worried about this dimension being too tight, because what's going to end up happening is as you tighten this, it's going to pull the truss rod a little bit towards it because it's captive by this flange here. So it's going to pull the truss rod towards it. And so this is, in theory, the longest that the truss rod will ever be. It should only get a little bit shorter as it expands. Okay, so now that that's done, we can go ahead and work on the fretboard. So let's go ahead and create a new component called fretboard. And let's sketch on this surface. Continue. Come on. My computer's freezing up. There we go. Okay. So what we want to do is bring in this line. Actually, let's bring in this line. Then go here like that. Make this coincident to there. I guess I actually didn't need that line. So let's delete that. Come up. And now the question is, what is our radius going to be? Now this is a highly debated topic in the guitar community. What's the perfect fretboard radius? It really just depends on your feel, what you like to play. A quick Google search found me this website from Thalia Capos, or Thalia, I'm not sure how to pronounce that, but it gives me the fretboard radius by make and model, the average fretboard radius on most of their guitars. So you can see as you go down the list, most of these companies hover somewhere in the 12 to 14 to 16 inch range for their fretboard radiuses. Fenders obviously typically have a more acute angle on theirs, not acute angle, but a tighter radius. So some of the vintage Fenders are only 7 1/4 and modern ones are 9 1/2. I've personally played a lot of Ibanez, and so they use a lot of 12 inch, a couple 10 inch. They have a couple big ones as well. I've personally really liked their 12 inch style, so that's what I'm going to go with. So I'm going to go 12 inch radius. Oop, that got brought up a little bit. Okay. We need these to be horizontal to each other to help avoid that. And then the question is, what is the height? So it's pretty common for fretboards to end up being around 1/4 inch tall. So with the 12 inch radius and 1/4 inch tall, should be good. So that's one side of it. Now we need to go ahead and sketch the fretboard at the other side. So let's go construct plane at angle from here. Actually, let's bring back our fretboard sketch. We want to do it from here because the nut is going to be out here. So construct plane at angle, 90 degrees. We'll sketch on that plane, and we're going to do the same thing. So let's just project in that line and hide our fretboard sketch now. Go line up, create an arc between the two, make these two horizontal. Let's make this, let's dimension to the top of that real quick. So 0.25 inches. Give this a radius of 12 inches. Now I want to check, now that I've got that modeled up, I want to see if this height is the same as back there. So we got 0.2133 inches. And what is this height? 0.2006. So that's actually a little interesting, because what ended up happening is we have the same radius, but because the neck is tapered, this line would kind of be over here on this. So this actually ends up being a little taller, which means it's going to taper down to the back. And I actually don't want that. So in this case, I'm not going to dimension the height. I'm going to keep my radius, but this time I'm going to project in this line right there, and then we'll make these two equal. So that way we have a straight line all the way back, but we maintain the same radius. Okay, so we've got that. So now all we need to do is loft between the two. I need to also update that sketch to not have, or to make this a construction line. There we go. Okay. So now what we can do is we can click here. We'll create loft from here to here. And let's hide these sketches. Get those out of the way. And let's bring back our fretboard sketch and hide the bodies. So we want to use these as rails just to make sure nothing gets a little hinky along the way. Hit OK. Bring back our body and hide the sketches. Okay, so there's our fretboard, but because it's a new component, it's not joined to anything. So what I'm going to do is I'm going to actually bring back that sketch and join the bottom edge of this front to, oh, come on, let me select it. There we go. To this line right here on the sketch. That way now I can't move it. So let's hide the sketches. Bring back our laminated top. And let's go ahead and give the fretboard a color, just like we did with the laminated top, so we can differentiate that from the neck. So I'm going to go ahead and give it blue for now. And that's already roughed in. So we've that quickly got the truss rod installed into the truss rod slot and got the main portion of the fretboard taken care of. Now what we need to do is cut the slots for the fretwire and then model in the fretwire. And that's going to take a little bit of time, so bear with me. Okay, so we need to create a plane that we can cut up from. So typically if you're making this, let's say you're using like an actual fret saw, you would end up cutting down from the top to a certain distance. What I prefer to do, so that way things don't get messed up later, is to actually create a plane and cut up. So let's go create offset plane. Let's hide our fretboard for a second. From here, now what we need to make this go up by whatever's remaining after the fretboard slot is cut. So let's look at the fretboard slots on StuMac's website. So I'm going to be using the wide highest fretwire because this is going to be a scratch build, so it gives me the most opportunity for fret dressing and getting everything down while still having enough metal. So we can see that the tang is 0.074 inches. So we need to come down from this corner 0.074. And so let's see, what is our height here? We've got 0.2006. So we need to do 0.2006 minus 0.0074, or 0.074. So 0.2006 minus 0.074. I'm going to check that real quick just to be sure. Let's go back. Where are we? There we go. 0.074. Yep. Okay. So let's create our plane from here up 0.1266. 0.1266. Yep. Okay, so that should, in theory, give us a distance from here to here of 0.074. Yep, so we nailed that. Okay, so let's sketch here. Let's go ahead and hide our bodies. Laminated top, hide the fretboard, hide the truss rod. Let's bring in the sketch. So now what we need to do is project in every one of our frets from our original fretboard sketch. So let's bring these in. So I probably could have just highlighted these all at once, but it doesn't take too long. Select them all. Oop, that one I need to select the whole row, so double click, hit P for project, bring those in, bring our fretboard back in. And now we can hide that sketch. So this is what we're going to be sketching on. So we do a midpoint rectangle. Oop, back rectangle or center rectangle. That. Select the midpoint, select this, hit a midpoint constraint so that way it centers it. Now according to StuMac's website, our fret wire is sized to fit a 0.023 inch fret slot width. So we need to go back and make this 0.023 inches. Now that made it too short, so bring it up. And let's make it stick out a bit further from the fretboard, so that way we can guarantee that we're going to cut all the way through, because remember there's a taper going down. So let's give this a construction line here and dimension that, let's say 0.125 inches. Just go off the fretboard by 125, and since it's a midpoint, it applied the same thing to the other side. So now all we got to do is basically do that for the rest of these, but in this case we can just make this one equal and make these two equal like that, and it's done. So you're just going to do that to every single one, and then I'll be back in a minute. Might do a time lapse here. Okay, so thanks for bearing with me on that. So we've got all of these fully constrained. Let's go and bring back our fretboard body, and let's do a cut extrude. Select all of these. It's also quite tedious, but you can see why we extend it off, so that way it doesn't end up cutting into the actual, or cutting short of the edge of the neck, or not the neck, the fretboard. So let's do that. Keep going. Every time I got to select 24. It's quite annoying. Okay, almost there. One more. Okay. Now we want to cut up through all. Hit OK. Take a second to load. Now let's go ahead and bring back our body so we can see how this all looks. Okay. So now not only do we have our truss rod slot and our truss rod installed, we've also got our fretboard with our fret wire, or not our fret wire, but our fret wire slots in place. So now what we need to do is go ahead and model the fret wire. This is going to be probably the most annoying or tedious part for everybody, but there's really probably two ways to do this. I'm going to show you the method that I use, but you can certainly do it any method that works for you. So go ahead and sketch on the side of the fretboard. We're not going to create a horizontal plane. We're going to sketch on the side of the fretboard. And what we need to do is we need to model one of the profiles of the frets. So if we go back to our website, what we see here, let me zoom in for you guys. We've got the crown width is 0.110, the crown height is 0.053, and the tang's 0.074. So what we need is a shape that looks like this. So we need an arc, make these two horizontal. We need a line coming in, a line down, a line coming over, line up, and a line connecting. Make these two, oh, those are going to already be horizontal. Let's give ourselves a midpoint construction line, so that way it's easy to dimension from the height. Make that vertical. Do one down to here. Okay, now what we need is we need a, what was that, 0.110 on the width here. 0.110 inches. That. And we need a, we know that the width is going to match the, sorry, I went to the review section, 0.023. So 0.023 inches. And the height is 0.074. Now we didn't give ourselves the height of the crown, so that's 0.053. 0.053 inches. Okay, so that should be basically fully defined. It just doesn't know where to put it in space yet. So all we have to do now is come here, select this line at the bottom, and hit midpoint. And as you can see, everything's lined up and we're good. So I'm going to show you how to do one, so that way it'll make sense what I'm doing during the time lapse in a moment. So what we can do is we can go, instead of extrude, we can go create sweep. We're going to sweep this profile up this path. Now you can see it's trying to create it for us, but we don't actually want to cut. We want to extrude it. So let's go ahead and actually hit new body. Actually, let's make this new component. Now, I learned from doing this already that this one works fine as parallel, but as you actually get down the taper, where it needs to be parallel ends up cutting, or actually ends up raising up part of the fret off of the fretboard up at this end. So what we're going to do is we're going to do perpendicular. Now what that does is it keeps the, if you imagine as this rotates, since this is at, no, this isn't at an angle, but since this is vertical, as it rotates over, when it hits this point, it's actually going to be angled inwards. So rather than adjusting and making it flat, we're going to make this perpendicular for now, and that'll all make sense why I did that in a moment. So if I hit OK, that's how you do one fret. Now, all we have to do is come back into this sketch before we added the fret, highlight all your lines, Control C for copy, Control V for paste. Then you can just paste that over, and that keeps all of our constraints, all of our dimensions. Make that midpoint, hit finish, and you can go back to your sweep, and then you can add this profile to the same thing. And all I'm going to do is I'm just going to copy and paste all of those frets down the row, go back to my sweep and add them all in, and I'll be back with you guys in a second. Okay, so that's all added back in. Let's go ahead and hit finish sketch. Now, obviously, the proper way to do that, I'm trying to skip some time, but the proper way to do that would be draw each one and give some constraints to all those lines so that way they're equal to each other, so you only have one set of dimensions that you can go back and edit later if you want to change to, let's say, the jumbo frets or the narrow frets. I did it that way to save myself time because I already knew this is the frets that I wanted to use. If you're still trying to figure that out, I would end up drawing those in, adding some equal constraints, and only having one set of dimensions that you need to edit. So let's go back to our sweep and let's add in more profiles. So here we go, keep going. There. This is one of the most tedious portions of the design because there's just so many of them. Okay, so now let me show you why I chose perpendicular. So as you can see, the frets are going to extend off of the fretboard. That's what we want. If I were to choose parallel, what ends up happening is it actually raises it above the fretboard, and that's not what we want because, well, obviously that's not what we want. But if we choose perpendicular, it does look like it just starts to clip into it just a little bit, but actually it's not too bad. It's just barely underneath, and that's fine. These frets don't have really any major impact on our design. They're most of visual aspects so that we can see what's going on and maybe do some nice renders, etc. But it actually does help us a little bit in setting the action height of our nut, or sorry, setting the height of our nut, so that way we can set our action. Words are hard. So go ahead and hit OK. Let that compute. Okay, so just like when we're actually installing real frets, our frets ended up extending off, and now we need to clip them off. So let's go ahead and go back to that construction plane that we created right here. Let's sketch on that. Let's bring back our fretboard sketch. Project these two lines in. And then all I want to do is come up from here. Let's go up a little bit. That. Connect those. Vertical. It's already vertical. And let's go up 0.125 inches. Let's make sure that it's clipping all of them. Yep. Grab that sketch that we just drew. Extrude up with a cut like that. Hit OK. Let's hide our sketches. Now I did something wrong, as you can see, because I went from the bottom of that. So I'm actually going to extrude or cut in two different directions. So let's go back to that. Go two sides. So we're going to go up all. So side one, let's do all. And then side two, we're going to go down. Let's go down 0.125 inches. Yep, so that'll just take us back to the bottom of the fretboard, roughly. So hit OK. And there you go. So now we've got the flush fret wire at the end on every one of these on both sides. So tedious, but that's the fastest way I've been able to do that. And since these are mostly a visual aspect of the guitar in the Fusion 360 space, I don't really care that these corners right here are just a little clipped off because we used perpendicular, not flush. But if you were really concerned about it, then you'd have to model and sweep each one individually, and it just sounds like way too much work. So I'm totally fine with that. Okay, so let's go ahead and get the nut in place. I realize we're kind of powering through a lot today. I need to get a lot of this done so that way I can finish this in the next episode, because the baby's going to be here in July and I'm not going to have much time after that to work on this. So let me go ahead and create a new component. Call it nut. Now there's a couple different ways you can approach the nut. I'm going to go ahead and use the captive version. So what I mean by that is I'm not actually going to recess a slot for the nut in place. I'm just going to put a dab of super glue and let the pressure of this, or the tension of the strings, hold it in place. But you could absolutely cut a slot from here down. And let me show you how you would do that. So open up our sketch here from our fretboard, and then we could just cut that down. So cut. We cut that down whatever dimension we need, and then extrude a nut up from there. But what I'm going to do is I'm just going to go ahead and extrude up. Now I'm going to extrude up an arbitrary amount, so 0.5 inches. And then what we're going to do is we're going to cut that away, cut the radius away. So let's sketch on this surface, and there's a good reason for that. Because remember, this is still tapering in. So if I sketched on this surface and cut back, then I'd end up clipping off just a little sliver of material here. So we want to sketch on this surface. Then we can take the radius of the profile, or the radius of the neck at that profile. Let's go ahead and hide our fretboard. And so all we want to do is go offset. Now let's offset it at minimum the height of the frets. That's the minimum you would want, because you don't want it lower than the fret, so that way the string's always touching. So if we go back to our frets, it's 0.053. So I'm actually going to just round it up and go 0.065 inches. So it's just slightly higher than the frets themselves. Now what we can do is just sketch up like this. Connect those dots, make it vertical, vertical, and make these two midpoint. Oop, and make that horizontal. Okay, then we can grab that sketch, cut it through to the back side of the nut, and now we've got our nut roughed in place. So let's bring the fretboard back. Now you can see that it's actually just slightly higher than the top of the crown, and that's kind of what we want. So I'm not going to, in my design, I'm not going to actually put in the string cutouts, what you would file in for the strings. I don't really care because I'm going to be hand making that anyway. I'm not going to be making that on the CNC. This just gives me a rough dimensions of what I need to actually cut, and that should do it. So moving on, let me hide the sketches. Now that we've got the nut, the fretboard, the fretwire, the truss rod, and the truss rod slot, actually, let me apply a quick appearance to that. So let's go paint. Let's make that red. Why not? Okay, so now we can differentiate it. Now, again, we will be applying proper appearances to this later. So now the last thing we're going to do is we're going to put in the bridge, and then we can go ahead and call this video a wrap. So let's bring back our sketch. Now the hip shot bridge, I'm going to be using a 6-string fixed guitar bridge. Now let's make sure we got the right one. So according to Hipshot's website, we have a 0.125 inch floor height is designed for action on guitars with non-angled or low profile necks, which is what we have. They also have a 0.175 floor height version, which is kind of for more Gibson style, where you've got an angled or a raised neck or bridge pockets, etc. if you wanted to recess it down. So since I'm not doing either of those, I need to make sure that the model I have is 0.125 inch floor height. So if you go to grabcad.com and you just search Hipshot, this guy named Alex D made an excellent model of a Hipshot bridge. So I just went ahead, I already have an account. If you don't have an account, create an account, and then you can just download that and import it into your model. So let me bring that up. Where is my bridge? Here we are. Drag that into our model. Okay, let's rotate that 90 degrees. Yeah, that's the right orientation. Okay. Hit OK. Let's see if it separates. Hold on. Yep, so see, some of the pieces here are kind of not joined together. So what I'm going to do is I'm going to select, oop, I dropped that into the nut. So let me delete that, go back to the main design and re-add it in. Okay, rotate this 90 degrees, hit OK. So I'm going to select the whole Hipshot bridge. I'm going to right click and say rigid group. What this will do is I don't have to apply any joints or mates. All I can do is just say the position all of these things are in, just lock them in place. So now let's go ahead and get that roughly in place. Ooh, I dragged that right into my model. Okay, let's get this roughly in place. Okay, so now we can use our fretboard sketch to go ahead and join these together. So problem is there's a little bit of a radius here. So what I need to do is I need to measure from here to here, 0.0098, so 9.8 thousandths of an inch. So let's go ahead and join this to that. So it's going to join it a little too high. So let's go minus 0.0098 inches. Okay, hit OK for now. Now I do realize this is elevated. So now we need to measure the distance from this surface to this surface, 0.125, because that's how much we raised the neck off of the laminated top. So let's go back to our joint. And let's drag this down 0.125 minus 0.0098. Hit OK. And let's make sure that that's lining up. Yes, that is flush with the bottom of the, or the top So now, obviously, this is in the wrong place because the end of this line is the end of your scale length. So that is in this line right here is in theory where the string should be touching the bridge. So let me bring the bridge back, or the bridge joint back up. Or actually, I need to measure the distance between here and here. So it's 0.2227 inches. So I'm going to copy that. Join. Come back in. 0.2227 inches. So that should bring this on top and roughly align the strings with the center of each of these. Now it's not perfect because of the string spacing that I gave it in Fret Finder 2D, but it's really close. It's only a couple thou off. So I'm perfectly fine with that. Now, the reason I aligned it this way is because this one is the furthest one forward. Now, typically when you're setting the intonation of your guitar, what you'll do is you'll set it as far forward as it can go, mount your bridge there, and then you can pull back as necessary. Maybe give yourself a couple threads going forward, but typically the high string doesn't need that much, but the low strings end up getting pulled back quite a bit. So that's typically how I would set the guitar bridge. So that pretty much covers it for today. We actually got a lot done in a fairly short amount of time. We ended up getting the truss rod and the truss rod slot in place. We got the fretboard along with the fret wire. Let me hide the sketches. There we go. Fretboard with the fret wire. We got the nut roughed in, and we got the bridge set. So I'm pretty happy with that. All that's really left to do is, because we did all of this, we set ourselves up so that way we now have enough information on where to place the pickups and the pickup slots. We now know where the strings are going to be going through the body, so we know where we can place our control cavity, where we can place our knobs and everything, and where we can place our tuners. So the very next episode, I'm going to go ahead and cover all of that, and we're going to try to wrap up this series. I may at some point in the future, when I actually start working on this guitar, or start building it in real life, I may go over the cam side of this, but for now, because the baby's on the way, that's going to be the next episode's going to be the last episode. So thank you for joining me today. We got a lot done, and I'll see you in the next couple weeks.